Alrighty, there we are. Good morning, good afternoon, good evening to people around the world. This is Martin Hubel, your host of the Db2Night show, ZOS edition or ZOS edition, depending on what part of the world you're in. And we're kicking off show number 91, Machine Learning and Db2 for ZOS with our very special guest, Terry Purcell. How are you doing today, Terry?
I'm excellent. Thank you, Martin. I appreciate the invite.
Yes, and we appreciate having you. We always love to have our people on from IBM. We've had, I guess we have a mixture between about 50% IBM folks and other gold consultants and other people we know and like that come on and speak for us. And our audience sure appreciates your participation. So let me get the housekeeping out of the way, and then we can move on to hear your presentation, because I'm sure people will want to hear more of you than me. Once again, here's our social networking stuff for Twitter and LinkedIn. Same old stuff. If you do use Twitter, use hashtag Db2Night for the Db2Night show. We appreciate you doing that to let us know what's going on. And here's our big disclaimer. I used to read this all the way through, but as I get older, I'm less in the mood. Basically, everything's being recorded, and everything belongs to DBI, and be nice, and copyright 2018. Have a nice day. Okay, quick announcements. We'll go through those, and then we've got some studio audience polls, and then we'll get on to Terry and the big show. Okay, here's our upcoming shows. We've got next month, we've got Christian Malero from M Consulting in Belgium. Christian is a DB2 Gold consultant, and he is very good at what he does, so this would be a good thing to talk about with distributed access again. And I've got a plug in there for my show on the LUW side. I'm speaking on indexes versus prefetch, how to win the fight. You've got to make these things controversial. And so that is a talk I delivered in iDoug in Malta last week, and it went over very well. I was really pleased with that. So if you've got any interest in DB2 LUW, you might enjoy that pitch. And in January 18th of next year, on the Z side, we have Dave Belke joining us, and he'll be talking about the best design and performance practices for analytics. I also saw that presentation at iDoug in Malta, and it's a good one. You'll want to be around for that. Okay. The other thing is for DBI, our founding sponsor of the Db2Night show, they have an infomercial that they run, and they'll be doing that on the 30th of November after the Db2Night show. And you might, if you have interest in the DBI tools, you'll want to catch that because it's pretty cool stuff. All right, moving along. Oh, we got Charlie back in here today, and I can tell you that he is being very insistent, and he's actually pawing my leg constantly. He can reach up to about my thigh from the floor, and he's wanting cookies, so I'll have to feed him to make sure that we don't have unnecessary barking and other things going on, but he just is not letting go today. And here's our sponsors, DBI at the top there. Klaus Brandt has always helped us with the mailing, and he's a stand-in speaker and host when we need him. And he's been a very good friend of the Db2Night show. iDoug as well has provided badges and other things, and we also run an all about iDoug show as well to make sure people know what's coming up at the DB2 North America, or the North American Conference, Triton, and of course yours truly in the lower right there. I wanted to put up a couple of pictures of Malta and let you know that the conference last week was as successful as the ones before. It's always good when the conference is successful because it means that we have no reservations about the next year's conference. And the first one is just a harbor nearby where we went to a restaurant or so and had a nice meal. I went back and took that nice picture just showing the building and the water around Malta. And the picture on the right is the trade show for just prior to it opening, before it got filled up with people. So it was, we didn't have a lot of vendors this year, but we did have a lot of paid attendees. And of course, when you really get down to it, we like to have vendors, but we like paid attendees just as much, if not a little more. I also, just to explain the next thing here, just for a bit of fun, I came across, every now and then I'm interested with people, what they do with in terms of advertising and the English language and stuff like this. So I came across this little sign beside a road, and I'm saying to myself, 60 shots at a bar for 20 euros. That's like, in U.S. money, that's under 50 cents a shot. I'm not sure if anybody shops at Costco, whether or not you actually, do you shop at Costco, Terry?
I do, yes.
Yeah.
I like buying in bulk, so I can buy 60 shots in bulk. That is good value.
Yeah, very good value, but it's also one of those things that says, when would this be a good idea to do this? So actually, with that in mind, we're going to do our polling questions. And what I'm interested in doing, and I'm going to ask our studio audience to help me out here, and I'll just actually run this first poll and let people answer that. When is it a good idea to order 60 shots? Never. If you're with 59 friends, to buy the entire bar a drink, when I don't care if I'm mugged in a foreign country. Or other, if you feel the mood, we have some people that like to write in things to us, and in which case they can use the Q&A tool and provide other fun ideas. And so I've only allowed people to do one vote, so it's interesting to see what people are saying here. It's for a bit of fun. And we're getting up to that point where I think those people that are going to vote have already done so. And so I'll close that off and share the result. And there we see that some people, I kind of agree the first one. I can't see why I would ever buy 60 shots at once, but other people are saying if you have 59 friends, that might be an idea. I'm not even sure if I'd want to do more than one shot in a bar. I don't think I've done it more than once or twice in my life. I'm just not that type of guy. But there you go. And I like that when I don't care if I'm mugged in a foreign country. Yeah, that's one of the things that I've learned, that being drunk away in a country that you're not familiar with is not really a good idea. Just putting it out there. Okay, let's move on and do the next one. The next one is standard questions here. What's the newest version of Db2 for Z that you have? We've got some answers there, mainly notice the Db210 has been completely removed. We're on to really new function mode, or whether you're on to version 12, just to see that information. And people are voting quickly on that. Thanks so much for doing so. It allows us to move along, and we're up to enough people, so I'll share the result on that. And today we have half of our audience in new function mode on 11. And then on 12 we have function level 100, and 12 function level 500 or higher. So that's interesting to see. We'll hide that and move on to the next one, which is what other DBMSs do you run? And this is again a standard question on people get to choose more than one. And it's interesting to me. Terry, I don't know if you were around back in the first days of Cod and Date when they used to say that Computer World called 1987 the year of relational database. And the caveat on that was within 5 years we were to have converted everything in the world over to relational database, or have plans to complete it within the next 5 years. Also at that time, the next year, it was the year of distributed database, and everything was supposed to be distributed. I remember that. I still quote that from time to time just because it's kind of fun. Because you still have an awful lot of people still using BSAM and IMS and other important mission-critical databases. But we have today most of our audience is Db2 LUW, and everybody has another mainframe DBMS like Oracle or SQL Server. It's good to know. Okay, let's move along. And the last one we're going to do right now is what hardware are people running? We had asked this last month as well, but nice to see what people have. And we're again voting quickly on this, so we'll get through this in a moment. And we'll turn it over to you. And all right, two or three more clicks and we'll be done here. So let me close that off and share the result on that. And there we see with 85% of our audience voted, most people are on either C13s or C14s, and that's good. Okay, with that, I'm going to hide that. That should make my screen visible again on moving your mouse. So I'll move forward. And do you see yourself there, Terry, with the words results beside you?
I do, Martin. I do see myself.
Oh, good. And you look marvelous.
Thank you.
I'm just putting that out there. And
all right.
We've got to keep the show lively here. So now I've turned over control to you. You just have to click that, and now we are seeing you're connected to GoToWebinar. Oops, and now
Yep. Quickly jumping into the presentation. Now I think you can see that.
It looks just fine to me. So
okay, excellent. And you mentioned Malta. I am borrowing my presentation from last week's in Malta. So thank you very much for allowing me to do that. And I have to say, IDUG Europe is always a fabulous conference. So
yeah, I enjoy it too. Great. I'm going to mute myself, but I will be available and I'll jump in with as people ask questions. Thanks.
All right, cool. Thank you very much, Martin. And again, thank you for the invite. So welcome, everyone. My name's Terry Purcell. I'm the lead designer for the Db2 for ZOS optimizer and also lead the machine learning in Db2 project. So I'm going to give you an update on what we've been doing in Db2 for ZOS with machine learning, and even talk about the problem we're trying to solve and how we can use machine learning to solve those issues and what we're looking at in the future of machine learning in Db2. So I'm going to cover, just to give you an overview of the query optimization challenge. And so let me just jump into it, because let's get to the real meat of it rather than spending time on the intro. So, I want to start with the query optimization challenge. I'm the leader of Query Optimizer in Db2 for ZOS. The query optimizer, or any optimizer in a relational database, is often a black box for many customers and DBAs. So let me sort of get to the heart of some of the challenges that any optimizer faces. We basically have a cost model, which is a set of formulas, and we take input from the catalog statistics. We take the SQL statement, and basically for each SQL statement, it comes down to a competition of the available access path choices, what we determine to be the lowest cost. Again, this is true for all query optimizers. Part of the goal to determine what the lowest cost access path, the most efficient access path is to identify the where clause predicates and estimate the degree of filtering that each where clause predicate provides. You can imagine, account number equals a value. Account number is typically a high cardinality column. If it's credit card numbers, it's bank account numbers. Any type of identifier, then there's typically a small number of rows that qualify for each account number. You get to other predicates. Maybe you're looking at gender, maybe you're looking at country code, and obviously there's going to be a lot more qualified rows for those types of predicates. And so the optimizer relies on the catalog statistics to look at the column cardinalities, how many distinct values. And some predicates, like I mentioned, have better filtering or lower number of qualified rows than others. But we get to some where clause predicates, and it can be very challenging for a query optimizer to estimate accurately the number of qualified rows. And the simple example that I use that really demonstrates the challenge of some where clause predicates is asking the audience, well, how many people in the audience were born before host variable or born before parameter marker? So that on this slide, birth date less than question mark. And if you think about it, it is an impossible question to answer until I give you the substitution value. If I provided 1900 0101 and said how many people born before 1900, my expectation is no one in the audience. Otherwise, you're a good 119 years old. And kudos to you for still working. So nobody qualifies. If I substitute 2018, 09, 01, so the 1st of September this year, then pretty much everybody qualifies, right? So you have some where clause predicates that, depending on the values provided, could qualify anywhere from 0 to 100% of the rows. And that means that some of those predicates have considerable risk if an optimizer thinks they're filtering or tries to assign an estimate to those predicates. Again, like I mentioned, very risky predicates to base an access path on. So that's sort of part of the challenge that a query optimizer face. Fortunately, of course, your SQL statements for your business, your applications often have a lot more predicates than just a range predicate like that. So we don't see a lot of situations where that's the only filtering, but it's just to show you some of the challenges that query optimizers face. So the trouble with these guesses or default filter factors, when we don't know the actual values, is, we may not predict accurately how you're accessing your data, what date range you're looking for example, because date ranges are often the predicates that are, have less thans, greater thans, betweens. Of course, they're not the only ones, but it's very common. Date ranges are that sort of predicate. And I think the best analogy I can come up with, because not everybody in the world is a query optimization buff, and in the machine learning space now, I'm talking a lot more to managers and executives and so forth. So not just DBAs. I'm using the transportation analogy for people to explain to them really, in their terms, what a query optimizer or an optimizer does. Think of it like a GPS, but a GPS where it also can tell you, well, you should take the bus now, or you should take the train, a GPS that takes in all your transportation options. So that's sort of like a query optimizer. It's trying to find the best access or best way to get from point A to B. And that's the same for an SQL access path, right? What's the best way to access the data, to retrieve the data that your query's requesting? And again, determining the best transportation choices when you're in a city, or going just from A to B is probably the best analogy to talk to people, who aren't query optimization people or DBAs. So to determine things like, what's the best route to go from A to B, you probably want to know where B is, in A to B, you want to know things like the available routes. And again, the more knowledge you have about where you need to be, and traffic, construction, available bus schedules, things like that, the more informed you are, the better decision you're going to make. And the query optimizer is exactly the same, right? So when you have where clause predicates that have parameter markers or host variables, we have to make guesses. And that's, again, why query optimizers can choose a poor access path, because the majority of the SQL world is host variables and parameter markers for the actual values that are seen by the DBMS when choosing the access path. So knowing that those inputs would help make better decisions typically. Okay, so that's the query optimization challenge. Then from a user perspective or a customer perspective, we do understand the complexity of SQL performance tuning and access path analysis for DBAs, for application programmers. It can be a complex and time-consuming task. You know, it depends on your skill level, your available tools. You know, what we like to see, you know, when someone hits a performance problem, we like to see answers, or, you know, asking the questions, do I have the right statistics? If not, you know, go ahead and collect the right statistics and build them into your statistics collection processes so you have the right inputs. So, you know, run stats is one of the key inputs, and we like to see appropriate and accurate statistics for the query optimizer. Similarly, you know, is the query well indexed? And when I say that, obviously you want the filtering where clause predicates to be able to match on available indexes, but also if you have risky predicates, you have date range style predicates, then often if they're not filtering, then they're not good candidates to index. And if a query optimizer is going to run into the issue of misestimating the filtering, then the indexing could either persuade the optimizer to fall into that trap or dissuade it from choosing that as a filtering predicate if it's not an available choice. But again, indexing, you know, appropriately for an SQL does take skill, does take tooling, because often you're trying to make a decision for one SQL without breaking 500 other SQLs. So, but indexing is another way to improve the performance of a query and get the appropriate filtering to be applied as early as possible. The next solution we like to see is often in an application program, the results are being returned and put onto a screen, for example. You know, kick screens are the good example, where you fill a screen and then scroll forward, or other, you know, more recent web screens or other types of search screens are scenarios where you may not return the full result. And if applications are not returning the full result on each query execution, having the optimize for n rows clause telling the DB2 optimizer or any optimizer that, hey, I'm not fetching the full result, I optimized for 20 rows or 1 row or whatever, that's important information. And without that, the optimizer can, you know, think, wow, there's 10,000 rows, I'm going to optimize for that, when you only want 20. So those sort of three, the stats, the indexing, and optimize for n rows, are three excellent ways to make sure, you know, the query optimizer has a good starting place. But when people run into performance issues, they often revert to using a hint or rebinding with AP reuse, or sometimes rewriting the SQL or changing the catalog stats, you know, to try and discourage a certain access path, or coding predicate tricks or query tricks, and they're not our preferred solutions, but we do understand that customers often have to quickly solve an issue and move on. But often those solutions that customers revert to don't really get to the heart of what the real issue is. So that's the challenge for one SQL. When you get to thousands, often our customers are doing a rebind on 10,000 packages or more because they've applied maintenance or they've migrated to the new release. And you can have a situation where you do a rebind of 10,000 packages, and suddenly, you know, 90% of the access paths stay the same, and you're happy with that. It's like no change, so I'm confident. But then 10% of the access paths change, or the packages have changes. That's 1,000 packages out of 10,000. That can be mind-blowing to consider. Well, how do I evaluate all of those and be confident that I can rubber stamp them and let those rebinds go through? How do I figure out that I'm not going to regress anything? And not only, you know, is one SQL, you know, tuning a challenge, but once you get into, thousands or hundreds or thousands, it's a scalability issue, right? So now it becomes unmanageable. So, we do understand the challenge for tuning one SQL and how mind-blowing it is to then, scale that challenge to hundreds or thousands of SQLs. Ultimately, as we enhance DB2, and I've got this on the next couple of slides, customers want improved performance, but they also want stability. IBM, we've been doing this a long time. Back in the 1970s with System R, IBM invented cost-based SQL optimization. Now we've been at this for 35 years. And we've been enhancing the optimizer over that time. And again, customers appreciate the performance we provide, but also the stability we provide. And though they have been core principles for Query Optimizer in our team for a long time, we're always trying to make sure that the statistics collection process is, as simple as possible and as integrated with, is easily integrated into your current processes. We've also delivered access path stability, plan stability, or plan management, since version 9, and that's been enhanced through the releases. And that does really provide a potentially quick and easy way to switch back if you do hit a problem. And customers have really appreciated that feature. But in development, in my team, every release, our objective is twofold. We want to continue to improve performance, deliver new access path choices that enhance performance and the stability of the Query Optimizer. But also, we don't want to compromise your 35 years of stability and the quality of the choices you already have. Okay, so that's sort of the quick overview of the challenge that we face in Query Optimization. Let me jump to a quick overview of machine learning. Obviously, I don't have time to train you all to become data scientists, but let's look to sort of some of the core principles. Machine learning, we've all sort of heard the hype, and if I look at it from my team, this sort of makes sense on the left-hand side of the screen. Traditional data processing, you develop an application program that runs on the computer, you feed in the data, that goes through the application program, and the result is output. The machine learning concept is more that you feed in data, you're feeding in the output of training results, and the end result is effectively an algorithm or an application program that can be reused for other purposes. And so what that means for my team and many other customers, many other users of machine learning, is you can more quickly develop applications, because if I look at Query Optimization, again, the DB2 cost-based optimizer, it takes a lot of skill to confidently enhance the optimizer and make the appropriate cost-based decisions in the development code. Often we like to see our developers having 5 to 10 years experience before they really become proficient. Now with the machine learning model, I can take intelligent new hires, PhD students, or just, very inquisitive new college hires, and I can apply them to the task of query optimization utilizing machine learning, and I have a quicker ability to have these new developers become productive and help them and help us in more rapid delivery of enhancements and features without requiring 5 to 10 years of application development experience. So, if I sort of, that to me is some of the core benefit for my team, and that applies to many customers as well. Of course, if I look at more the sort of the marketing perspective of machine learning, you look on the right-hand side, it can identify patterns, machine learning, by looking at large amounts of data and find patterns that we couldn't find from a scalability perspective. Build models to predict behavior such that, again, from the query optimization standpoint, once we build models as sort of that application program perspective, that then my future decisions can take advantage of that model or that algorithm and predict an outcome in future, again, more easily than needing that strong skill in query optimization. This is a marketing slide, I will admit, but I'll bring it back to sort of the reality on the next slide. Organizations can exploit machine learning. Again, this is part of the hype, right? And on the right-hand side, there's words and there's pictures. That is incredibly impressive because usually we don't have pictures in an optimization or a DB2 presentation. So I just want you to be wowed by that. That's very exciting. On the left-hand side, look at the marketing perspective here. Machine learning learns and adapts, avoids making mistakes, provides faster, deeper insights, resulting in just complete wowness. And part of it, this is me a little bit being tongue-in-cheek, trying to be a little humorous, because in our world, our customers using DB2 for ZOS, this all sounds nice, this sounds fantastic, but our job in DB2 for ZOS, again, is to maintain the stability. So the excitement around machine learning has to be tempered with the reality that our customers are mission critical. So moving on to the next slide, what does that mean for us in DB2 development? I take that marketing slide and I turn it into my reality, your reality, as users of DB2. So with my arrows pointing to that marketing wowness, look on the right-hand side. What am I asking you? Well, constantly learns and adapts, avoids making the same mistakes, which means if it's avoiding the same mistakes, it meant that it made a mistake. Okay, so let me ask you the question on the right-hand side. How many optimizer mistakes can you tolerate while we learn? Okay, a little note underneath. This is kind of a rhetorical question, right? Because I know the answer. You don't want any mistakes. You don't want any optimizer screw-ups, right? So we understand that. So again, this idea of machine learning, adapting and trialing and erroring sounds great, except once you get into a mission critical environment. So to me, that's not it's not a complaint. It's part of the challenge, right? And we are obviously embracing that challenge. So the stakes are a little bit higher than, can I say, Netflix recommending a movie that I really didn't want to watch, right? It learned, but so what? Or an online retailer suggesting that I buy certain products and I'm not really interested. That the stakes are a little bit higher for our customers. And a really good analogy that someone gave me recently was, think about a self-driving car. You wouldn't want it to mow down 17 pedestrians while it learns into safety, right? So typically, we're not as much dealing with life and death situations, but maybe you get the point that some applications of machine learning or AI are less mission critical or less critical in their trial and error capability than others. And we clearly want to take that seriously. So again, part of my goal is to, turn the hype of machine learning, which, believe me, it's a massive opportunity for us in DB2 and for all of our customers. But also, we have to deliver it in a measured way, and I'll talk about that, of course. So some terminology. The type of machine learning that we're using is supervised machine learning in DB2, where you're basically training a model based upon a set of known inputs and a set of targeted output values. To bring it to an analogy that people understand, I really like the real estate market style analogy, the house prices, because people can relate to that. If you go to sell your house, next week, your real estate agent, is going to feed in all the criteria about your house. It's a 3-bedroom house. It has a 2-car garage, 2 bathrooms and this many square foot or square meters or whatever. And the location, of course. And using machine learning, you can have fed in all of the prior sales history with, again, all of those criteria. And the models will ultimately learn which of the input criteria, whether it's the number of bedrooms, the square foot, the number of bathrooms, the location, which of those criteria carry the most weight in the final decision. And so when you feed in a new house details, then you're likely to get back a good predictor based upon historically what has occurred. And so again, these machine learning models, they're really agnostic to what the problem is you're trying to solve, but you basically feed in a bunch of features or individual pieces of data, and the machine learning model, or the goal is to find which input features are the most important in determining what the final prediction should be. So again, I like the house price analogy as sort of the example that most people can relate to. And I jumped forward, using terminology. The term we use is features, as the pieces of information that you feed in. And again, the house price analogy, it's all the criteria or all of the details about the house. In query optimization, it's all of the information that the optimizer would use. And again, machine learning can find which input criteria really carry the most weight in predicting a future score or a future result. I think this is my last slide on sort of the understanding machine learning. The concept of train ops, or sort of the approach that, another approach that I really like with machine learning that the infrastructure brings us, is the ability to select the input values or the features. Often that's the data scientist that's coming up with the input criteria or features. You feed in all of the thousands or millions of pieces of historical data into model training, and out comes a machine learning model such that when you input new features for a future request, the model will have determined, based upon the historical data, which of those input features, again, will carry the most weight to produce the final score. And so you do the training in an offline process, and then you do the scoring as part of the future prediction. So exploiting this in sort of the DB2 or query optimization space, our goal long term is to extend machine learning to many use cases in DB2 for z/OS, looking at where we can make DB2 more self-tuning and self-managing. And don't worry, if you think about sort of the automation, autonomics, we're not putting anyone out of a job soon. But still, as DBAs and application programmers, managers, I'm sure you understand that there's a lot of opportunity for DB2 to exploit machine learning to improve the decision making, because a lot of it is outside the scope and skill of DBAs today. Even if you have the skill on a scalability, the number of DB2 subsystems, the number of tables, indexes, queries you have, it becomes unmanageable. So you really need more automation, autonomics, and machine learning is the way to do that today, right? So in DB2, it can be applied to query optimization, package rebinds, choosing what to rebind when, memory allocations, ZPUMs, buffer pools, when to execute utilities, percent-free allocations per object, IDA offload decision, et cetera, et cetera. Really, the possibilities are endless in DB2 and any DBMS. So in DB2 itself, DB2 development, for over 1.5 years now, we have been prototyping, researching machine learning in DB2. And we started with query optimization, and some obvious reason why we started with query optimization, because I mentioned earlier, we have a cost model, and so this concept of models feeding in features and a decision on the coming at the output is already a concept we have, and again, the DB2 optimizer is the best analogy for the concept of a model, right? We have a cost model. What we've been lacking is feedback, learning, and again, machine learning gives us the training infrastructure and the more rapid development capability that I mentioned earlier. Anyway, so what we've been working on is constructing machine learning models to assist the DB2 optimizer to see, ultimately, as a research prototype, to see, could you replace a 35-year-old optimizer with machine learning? We had models basically evaluating the cost of queries from training. And what that means is you could customize an optimizer for each customer, for each workload, for each environment. And the machine learning models would stay current and learn and adapt and basically adapt to your workloads and be customized to your application workloads. So that's what we investigated. Again, could we improve the optimizer with machine learning? We looked at, again, supervised learning, use different types of algorithms or models, neural networks, random forest, linear regression, and the end result, there's a couple of things. Now, of course, we can all make jokes about, an optimizer that starts to learn on its own, and we all think about the Terminator movie. Now my queries are coming to kill me. We're not expecting that to happen, but there is a challenge with once you start to have machine learning learn specific to your environment, it becomes a support challenge for you, for us. I don't think a customer is going to sit here and say, "Oh, we got an access path regression," and your management will accept. "Oh, don't worry, it'll within the next month it will learn and solve it itself," right? That's not really a model or an approach that customers are going to accept. So we still need to be able to support. You need to be able to manage your DB2. We need to be able to support DB2. So having that truly customized machine learning optimizer is sort of moving away for our ability to control that, but maybe in the future, right? But not so much now. The other part about that is if you think about it, to truly learn in your environment, you want to do a lot of training on your workloads, and that becomes CPU intensive, right? So that is also another challenge of this concept of completely replacing an optimizer with machine learning. But again, we use this analysis to evaluate the viability of this. And again, like I say, there's some practical reasons why this isn't the approach to go today. But what we did do is we used machine learning to validate the optimizer cost model, and we found some deficiencies that haven't been uncovered by customers, and we've addressed those via APAR. And we can continue to internally in DB2 use machine learning to continue to validate DB2. After that work, we looked at the safer approach of using machine learning to improve the quality and the effectiveness of the inputs to the cost model. So instead of looking at a focus where you want machine learning to replace the optimizer, we exploited or investigated an approach where it was augmenting and improving the inputs to the existing cost model. And a good analogy that was given to me that's on this slide here is so machine learning, we're not targeting it to replace the query optimizer, just like IBM Watson is not replacing an oncologist. In that scenario, IBM's Watson provides an oncologist with better inputs for patient care decisions, right? So we're doing the same approach. So that phase 2 then, focusing on what the optimizer doesn't know, we looked at the biggest inputs to the optimizer that are estimated today. The first one, the example I gave you with birth date less than parameter marker or host variable, host variables and parameter markers are one of the biggest unknowns. What are the real values that you're using historically, and can we predict what it'll be in future? So the execution time values, that's one area. The other area that I briefly talked about on tuning was, well, what is the real application behavior? How many rows are you fetching in the application? And that's another unknown if customers aren't coding optimize for n rows or fetch first n rows. So looking at those two major inputs that the query optimizer has to guess or estimate today, that led us to our continual research and development, and then now to a new offering of Db2 AI for ZOS, or Db2 ZAI, which is machine learning in Db2 exploited by the query optimizer. So we're enhancing the optimizer decisions now with machine learning targeted to your application environment, your workloads. So it can learn the patterns from your workload, what the where clause predicate behavior is, and how your applications are accessing the data. Built on top of IBM MLZ stack, and the key important part about using machine learning in Db2 is we leverage the MLZ services without requiring data scientist support. Db2, so this can be managed by DBAs, application programmers, or system programmers. Db2 manages the model training, so the model creation, the training of the model, deployment, monitoring, and retraining of the models. Again, not requiring data scientist support to manage machine learning in Db2. Prerequisites, Db2 so it was good to see that approximately half of our attendees were on Db2 At this stage, we require function level 503, which is very recent, and it does require machine learning for ZOS, or MLZ. Looking at the architecture, the pun is intended that this is the black box of the optimizer. Again, it's a black box to many, many customers. On the right-hand side, instead of the green and the yellow, is the machine learning pieces that come with MLZ. So the scoring service, on the bottom, the machine learning model services, IZODA on the right-hand side, which is the Spark runtimes. In blue is the new pieces for Db2 ZAI. And basically, again, like I mentioned, we're trying to integrate machine learning into existing Db2 processes. So once this is enabled, when queries execute, we'll write to new pseudo catalog tables that we call performance history tables. And that happens automatically while the queries are executing. We collect information about the execution performance, similar to like dynamic statement cache data, and also the host variable values. Then we have zip eligible tasks that sort of like daemon tasks or learning tasks that will wake up at periods of time and read those tables. And once thresholds have been reached, we can determine that it's time to create a new model or to retrain a model, for example. And the user interface on the bottom of the screen is how how all of the activities are coordinated, how they're started, how the connection is created. It's all managed through the user interface. On the off-platform side today, we support Linux on the x86 side, or Z Linux for an all-Z implementation. This is just an example of the dashboard. I mentioned that we are trying to have all of the activities through the user interface, and it manages the connections to Db2. It will automatically, you can click on a button to start machine learning on that Db2 subsystem, etc. But it will identify the SQLs that are candidates, and it will provide them as once the execution gets to a certain point, we will automatically create a model, and then on the left-hand side, once you've done a rebind for static, or dynamic is just automatic next prepare. If a model has been created, the rebind will automatically pick up the model, and then you'll see packages that are using machine learning, and you can look at the performance history, the results on the right-hand side, and you can drill down on any of the buttons to see the package information. On the left-hand side, it's saying 43% of packages using machine learning. If you click on the blue, it's going to show you packages where a model has been created, but you haven't yet done a rebind. Again, we're still leaving rebind in the hands of customers. We expect customers will still want to maintain control. There's a little sliver there in the red on the left. The number of packages right now that haven't reached a certain threshold haven't created a model as yet. You can, on the right-hand side, you can click on any of the, showing you the performance metrics. It'll show you what the current performance improvement is for the packages that have been identified as candidates and currently executing with machine learning. So you can drill down, from the user interface. Not to leave the data scientists out, although we manage all of the data science experience, we do provide a model dashboard that shows you the types of models that are deployed by Db2z AI, and how many models have been created and how many times we've scored using those models. So those metrics are just there as an FYI, again, to show you that the models are actually being utilized by Db2. So a little bit more on Db2z AI. I sort of went through part of the challenge for a query optimizer, and I mentioned that the optimizer, any optimizer, Z or LUW, we have to make default estimates based upon column cardinalities, etc. What the filtering is for those where clause predicates. But being able to predict what the real application behavior is allows us to customize those filtering estimates or filter factors, customize them to your workload. But we're not changing the core of the query optimizer, but we're augmenting the inputs and customizing, like I say, the filter factors to your application behavior. We're seeing really good performance improvements in our Db2 environments, as much as up to 25% for some workloads, where we're able to understand the application behavior and predict better filter factor estimates. We also see better reliability in the access path choices, so less fluctuations because the inputs are more reliable now. For static SQL, we do require package rebind, and I just mentioned on the previous couple of slides that we still leave that in the DBA's hands, or whatever application process you use to go through your binds or rebinds. I think we're a little bit away from customers really being comfortable with us completely automating even some of those decisions. But the Db2z AI model or performance dashboard does give you a list of the packages where a model is currently available, and you can choose to rebind those, or maybe your next rebind cycle, whenever that is. Maybe you do it monthly, maybe you do it quarterly, maybe you do it once a year. Whatever your existing rebind process is, you don't necessarily have to change your rebind process, unless, of course, you'd like to take advantage of that model before your next regular scheduled rebind. Typically, the question we start to get, now that we're talking about, hey, we have machine learning now in Db2, it's a new offering, and we think you'll see value. The obvious question that we get back from customers and IBMers that work with our customers, really, how do I know if my workload will actually benefit? And it's in a tongue-in-cheek or humorous way, I I smirk and I respond with my own question. I ask, are you asking me, can you tell me what the DB2 optimizer doesn't know before machine learning has learned what the DB2 optimizer doesn't know? And if they were listening well enough, they say, well, yes, that's what I'm asking. Okay. So if I really knew that, I probably wouldn't need machine learning to learn what I don't know. Right? So now I'm even confusing myself. But I think you get the point. To really predict what machine learning is going to uncover is a little bit difficult, right? But that doesn't mean I don't understand, or we don't understand, the need for people to want to know, will they get a benefit? Typically, I'm going to say we will find opportunities for performance improvement. I know this because we do in Db2 for ZOS, and I'm sure other databases do too. We have to make safe decisions. We have to make access path decisions that you're comfortable with, that are reliable. And so some of these risky predicates, we take conservative estimates on how they could impact the access path. So we know we're leaving performance opportunities on the table because there are no rewards for taking risk that could cause an access path regression. So that's pretty common, that we have to take conservative, make conservative decisions in today's query optimizer. Once we improve the reliability of those decisions, we could make access paths that are more targeted and more optimal for that set of inputs. So we know that to be true. We just haven't told you about that in the past because we didn't want you to think we're delivering suboptimal DB2, but that's our reality. Customers want reliable, safe access path choices that perform well rather than could perform fantastic or disastrous based upon whether our estimate was right. But given the need for people to want to know, could I benefit from DB2Z AI? We do have a couple of SQL scripts that you can run against your explain tables and catalog that look at the number of SQLs that you have. It can be static or dynamic, where there is risk of suboptimal access path choice based upon the where clause predicates. You would need to contact your IBM rep for this DB2Z AI analyzer. We like customers to ask their IBM rep because there's a couple of setup steps that there's a presentation that they've seen that helps the customer walk through what they really need to make sure that they're running this correctly. It's a short, it's a quick process, but there's just a couple of setup steps. But again, contact your IBM rep to be able to run these scripts. The scripts actually run on version 11 or version 12. Okay, so what's next for machine learning in DB2? We've delivered our first release. We're working on the next deliverable in a continuous delivery model. But we're also continually taking customer input about what areas of DB2 would you like us to apply machine learning to. And look, this is a journey, but we are committed to safe and cost-effective exploitation of machine learning. I talked about, we understand you don't want a lot of failures while we learn. You don't want expensive training process to learn based upon, all of your historical SQL execution or your whole system behavior. We understand that there's a cost challenge to that style of large-scale learning. Here's some links to more information about DB2Z AI. Our documentation is up to date. And so again, there's links to our IBM Knowledge Center in there as well. And right on time with 1 minute to go, that's the end of my presentation. So I thank you for hanging in there. And over to you, Martin, for any of the final wrap up or any questions that might have come my way.
That's fantastic, Terry. Thanks so much. And you didn't necessarily have to finish on time because I'm sure our audience would hang in there. For some reason today, I think you explained everything so well, we don't have any questions for you, which is unlike our audience, really. We normally do have a number of people that are pretty vocal. But with that, I'm going to take back control. And I just need to get over here, click that, click this, click that. And now we're back to my screen. And I'll just remind people, we'll give you back your lunch hour. Replays will be posted on the Db2Night show page. Terry, I was checking, and I don't know if this presentation made it onto the European CD, so if you could send your slides over to me, I'll post them on our replay blog, and certainly our audience will have access to the PDF along with the Windows media file and MP4. That would be fantastic if you do that, please.
I will do that.
Thanks so much. And with that, I will just give our final slide there, which gives yet another little plug for the DBI, and our sincere thanks to DBI for making it possible for us mainframe folks to be on this show. And with that, I'm going to cue the music. Wish everyone a great weekend. Thank you again so much, Terry, for your excellent presentation. I know our audience loves hearing things right from the lab, and it's always good to hear your voice. So with that, here I'm going to turn on the music and wish everybody a great weekend. If you're shoveling snow like I will be careful out there, and we will see you on December the 14th for our next ZOS show. Take care. Bye-bye all.